Welcome. In this video I'm going to show you how you can determine Cohen's W with Python, which is an effect size measure that could be used for a goodness of fit test. I'm using Anaconda and then Jupyter Lab, and I'm running Python 3, and I think this is Python 3.9.7. This is the formula for Cohen's W, and the way it was originally written, where pi are the expected or the observed proportions and qi the expected proportion. We can also even convert from Kramer's V, another effect size measure, the W. So that actually helps with creating some kind of interpretation table. Cohen actually gives thresholds for small, medium, and large, and they are at 0.10, 0.3, and 0.5, so I interpret that like this. To show you how you can do this with Python, I'll first need to load in some example data. If you've never used pandas before and you want to follow along, you'll probably have to install it using pip install pandas first, and then you can import the library pandas. That gives access to the read CSV function, which then can load my GSS 2012, which stands for General Social Survey from 2012, and A means that I slightly adjusted it. And we can see the first 5 records by using the head command or function, and you'll see it has a bunch of data from different people. There are actually 706 columns in here. I only need one of those, the marital status, which was labeled MAR1. So I'll select that one, and I'll use the values count just to get the frequencies or the counts, as it were. So in total there were 314 people who indicated to be divorced, for example. Now we can get Cohen's W by using the chi-square effect size measure function from stats models. Again, if you've never installed stats models, you need to do that first and then load the function in. This function actually works based on that second formula. So if I scroll back up, it's oriented on this one, the original. So we'll need the expected proportions and observed proportions. In order to do that, I'll need the total number of samples, so my sample size. And if I divide each of my counts, my frequencies, by that sample size, I get my observed proportions. So here they are. So about 50% of all the people indicated to be married, and there were 1,941 people in total replied to this question. Now I'm going to assume that each category was equally likely to be chosen as my hypothesis, so that's going to be simply 1 over k. K being the number of categories, so I can use len to get how many categories I actually have. And then simply say to 1 over k, make that an array and repeat that k times. So that way I have 5 categories, and I should therefore have 1, 2, 3, 4, 5 times 0.2, because 1 over 5 is 0.2. Now I can finally use that chi-square effect size measure function. First the expected proportions, then the observed proportions, and we get 0.80. Using that table, I can classify this now as large. So that's how you can relatively easy get Cohen's W from using Python. The formulas you can actually also follow along. For that, if you want to use this formula, you will need the chi-square value. I have a whole other notebook explaining that. So that requires chi-square, and then you can actually use the chi-square function on the my counts, and you get the chi-square value. That then needs to be divided by the sample size, so that's that one we already have. And you need to take the square root, which is the same as raising it to the power of a half. So this should also give that 0.80. Or if we want to follow along the original formula, we can simply say, well, you take the observed count, so my proportions minus the expected proportions. You square each of those, and then you divide all of that, each of them, by the expected proportion. Take the square root out of all of that. First sum all of that, and then take the square root. So that should also give the 0.80. And that's how you can determine Cohen's W with Python. Hope this was helpful.